Hi, I'm Herb Gross, and welcome to our web-based workshop, which we call Math as a Second Language. Knowing that you only get one chance to make a first impression, I tried very hard to see how I should introduce myself so that we could sort of bond instantly. And a story came to mind about a raging flood. Waters are raging very high, very violently, and people are sitting on rooftops waiting to be rescued. And as they're looking down, they see a hat floating downstream, which seems pretty natural. But about 50 yards downstream, the hat reverses direction, starts to float upstream. And it kept doing this, upstream, downstream. And the man turned to his wife and said, "Isn't that a miracle, how that hat keeps reversing direction every 50 yards? And the little old lady on the next roof said, "Son, that's no miracle, that's Grandpa. Just before we went to bed last night, he said, 'Emmy Lou, tomorrow morning I'm mowing the lawn come hell or high water.'" And I thought this was a beautiful story for an introduction, because that's how I visualize elementary school teachers in a way. The work piles up, the support system is not always what it should be. And what happens is, unlike your counterparts who teach at the middle and high school and have only one course to worry about, you have to worry about almost everything. You come to a math workshop one time, the next time it's language arts, then maybe science, then maybe social science, and there's so much on your plate and so much to do. And because you have to spread yourself so thin, it's understandable that some of you may not have the depth in mathematics that your middle school and high school counterparts have, because that's all they have to concentrate on. So that's what we're going to be trying to do in this course. It turns out that these lectures are just one component of what we call Math as a Second Language. And in fact, let me just give you the website. We call it Math, www.mathasasecondlanguage.com. And it's going to have an entire arithmetic course on it. It has the Common Core standards, by grade level, by activity level, because we recognize that your time is very, very valuable, and you sometimes don't have time to assimilate new material and still have time to realize how you're going to transmit this to your students. We have lectures, video, animated PowerPoints that will allow you to work interactively with the students. We have worksheets for the students. We have animated PowerPoints to expand upon the lecture material, the video lecture material, and just about everything you might need. Now, what happens is, a lot of people say things like, well, video isn't as personal as live classroom. Well, I don't know. It seems that when you're in a live classroom, you're conscious of all the people around you. You're conscious of the fact that the instructor can't concentrate just on you. So we've tried to arrange a studio type of presentation where we at least try to give the illusion that you and I are just talking personally to each other. Now, there's advantages to video lectures that sometimes people don't realize. Have you ever been in a classroom and you're copying notes and the professor erases the board before you finished? This happened a lot of times. You're not going to say to the professor, "Could you please rewrite that? I wasn't through copying it." Well, let me just show you something here. See, with videos, not only is it face-to-face, it's on demand. You can watch it whenever you want. If you're busy doing something, if you have other chores to do, it's waiting for you whenever you want. If I'm erasing the board too fast, meaning I switch a card too fast, just put on pause. You can keep a frame on as long as you want. If I'm boring you because you know the stuff already, fast forward. If I go too fast, rewind. You know, they have a joke about it. They tell it as a joke. They say, this guy was so slow, it took him 2 hours to watch 60 minutes. Well, the funny part is that's not a joke. It's actually true. These will be anywhere from 12 to 20 minutes in length, but you can make them as long or as short as you want just by using the pause, the rewind, and the fast forward as you see fit. So hopefully you'll see that I'm thinking hard about trying to help you, but the next question should be, who am I? Well, if you Google my name, Herb Gross, and put in the word math, a whole bunch of stuff comes up. And most of it centers around a video series I made for MIT called Calculus Revisited back in 1970, a long time ago, black and white, talking ahead. It's on the internet. There's been almost 1 million views of it just in the last 3 years. And so you might ask, quite justifiably, great, he can do calculus. What does he know about teaching third graders? And the answer is, if you ask that question, you're absolutely right. All of my experience has been at the college level. But let me just tell you something. I was in the classroom for 50 years. 10 of those years were at MIT, 5 of which when I developed Calculus Revisited. It was during the time period 1968 to 1973. From 1958 to 1968, I was teaching developmental math at a community college. From 1973 till my retirement in 2003, I was teaching adult learners at the community college, people who were math phobic, who had somehow slipped through the cracks in their K through 12 math background. So while I haven't taught at elementary school level, I've seen students who, in a sense, were middle-aged elementary school students. In other words, there were people in their 40s and 50s and 60s taking arithmetic because they didn't get it the first time. So what happened was, by necessity, I was kind of forced into trying to find a different way. I mean, I think it was Einstein who said, insanity is doing the same thing over and over and hoping to get different results. So my feeling was I had to find something different that would help students learn better, okay? And so the situation is, we talk about numbers, but what we see are quantities. If I say to you, show me what the number 3 is, you might likely go like this. And I say, look, I know what 3 fingers are. I want to know what 3 is. You see, we talk about numbers, but in our mind, what we see are quantities. A quantity is simply a noun phrase consisting of an adjective, which is a number, that modifies a noun, and we call that a unit. So, for example, while we've never seen 3, we've seen 3 apples, 3 people, 3 tally marks. Okay? It's the same thing as saying we've never seen blue, but we've seen a blue shirt and we've seen a blue sky. Now, the word blue means the same thing in both cases, but as a quantity, a blue shirt is not the same as a blue tie. So we're going to use tally marks as a way to visualize what numbers are. So when I say 3, as long as you're thinking 3 fingers, let the fingers represent tally marks. Now, the other point, of course, is that we can help the students visualize things better by using square tiles. In other words, instead of using a tally mark, you see, we can do something like this. We visualize 3 as 3 tally marks, but instead we'll visualize them now as 3 tiles. And so the 3 is modifying tiles, and the 3 tiles is a phrase modifying whatever you're talking about. It could be 3 dresses. It's the same thing as saying the phrase a blue dress. Blue is an adjective that modifies dress. If you say a dark blue dress, dark is another adjective modifying blue, and dark blue is an adjective phrase that modifies dress. So basically, that's what we're going to do. We're going to visualize numbers as adjectives that modify nouns. And this is important because when you see the symbolism of math, it's very easy to become confused. I call this the language versus the concept. You're a little kid, and you're dividing your candy with a smaller sibling, a younger sibling, so you take the giant share, and you count 2 for me, 1 for you. 2 for me, 1 for you. No problem that way. If you say 7 for me, 8 for you, 7 for me, 8 for you, you can see you're dealing with bigger numbers, but here you're keeping more than you were giving away. Here you're giving away more than you're keeping. So you recognize that 2 for me, 1 for you is a better deal. You don't necessarily see that this is what we write mathematically as 2/3, 2 out of every 3. 7 for me, 8 for you means I'm taking 7 out of every 15. I have seen students look at 2/3 and 7/15 and say 7/15 is bigger than 2/3 because the 7 is bigger than the 2 and the 15 is bigger than the 3. But they'll never make this mistake. See, so again, we have the problem that if we can visualize numbers as quantities and see what's happening, certain things that bother us from the rote memory point of view won't happen. Let me tell you a true story. Well, at least true as I remember it. When I was very young, I remember learning addition, and my father decided to test me. And he said, "Son, how much is 4 plus 1? Well, right away I knew the answer was 5. He says, "Good. Now, how much is 3 plus 2? And I said, 5. He says, "How can 3 plus 2 be 5 if 4 plus 1 is 5? And I was crushed. Had no idea what was happening because I had memorized. Now, watch what happens in terms of tally marks. Here's 4 plus 1. I simply take one of these tally marks, move it over to here, and now it's 3 plus 2. And this is all you have to know when you're dealing with tally marks. It's an amazing rule of the game, and it covers just about everything. In fact, when I tell it to you, you're going to think it's so obvious, why is he even mentioning it? And here's the key point of our course. The number of tally marks in a group does not depend on the order in which they are counted or on the way in which they are arranged. Is that very hard to learn? No matter how I have these tally marks arranged, I can change them around, and no matter how I change them around, the number is going to be the same. Now let me show you how this can work from a rather simple point of view. You know, a perfect square is a number where the tally marks or the tiles can be arranged to form a square. So you see the number 1 can be represented by a 1 by 1 tile. The number 4, 2 times 2, okay? That's the perfect square. So what are the perfect squares? They're 1, 4, 9. Now here's the interesting thing. If you add consecutive odd numbers starting with 1, you get the perfect squares. 1 is a perfect square. 1 plus 3 is 4. That's a perfect square. 1 plus 3 plus 5 is 9. That's a perfect square. 1 plus 3 plus 5 plus 7 is 16. I didn't draw that one. But let me show you how we know that's going to be a perfect square. Here are these tiles. They're arranged in a certain way. If I take these tiles and arrange them, I don't know how this is going to show up, but we'll see, in an L-shaped pattern. This is 1 tile. Isn't this 3 tiles? This is 1 plus 3. In a similar way, if I already have 1 plus 3, now what am I going to do? I'm going to tack on. How did I get from here to here? I added 1 more column and 1 more row. I added on another L-shaped region. How would I get to 16 from here? I would simply add on another L-shaped region. And by the way, if my drawing is bad, that's great, because I want you to see you don't have to be an artist to be able to understand this stuff. So this is about where I want to be for our first lecture. I hope we've gotten acquainted by now. I hope that you realize that my goal is to help your students better internalize mathematics. There's another Einstein quotation I'd like to use to close on today's session. Einstein once said, "The important thing is to always keep the important thing the important thing." The important thing wasn't to have new standards. The important thing wasn't to have kids memorize by rote enough material to pass a test. Look what's happened so far. We have all kinds of standards. Kids are doing more and more, passing these, No Child Left Behind, the math exams in various states, the exit exams. Yet the number of students taking remedial math at the college level hasn't gone down yet. And somehow or other, what we've forgotten is that the important thing wasn't to get kids to pass standardized tests. It was to get them to internalize mathematics. You will hear a lot of talk about how we need more scientists and mathematicians. Well, that may be true, but in my mind, that's nothing compared to the 80% of the student population that has no intention of going into a math science-oriented field. But they go through life so frightened of mathematics that they avoid jobs that would promise more upward mobility just because they're afraid of math. My goal is, while I would love to see students become good mathematicians, that's a secondary thing. The important thing is to make sure that they are not afraid of the subject. I want you to be as comfortable as possible in presenting the subject. Otherwise, it won't come across as being natural to the students. And I think we will just have a good time together, working hard and staying young, so to speak, being young at heart, enjoying the quest for knowledge. And I'm looking forward to going through this course with you. And until next time, have a great day.